Today in chemistry, we will be learning about the gas laws. In regards to the end of the year AP chemistry test, there's an average of 4 multiple choice questions and 1 free response dedicated solely to the gas laws. The first gas law is the ideal gas law, PV equals nRT. This is an equation for gases at its ideal conditions, with high temperature and low pressure. In this equation, P stands for pressure, and the units are atmospheres, V is volume with liters, N is moles, R is a constant of 0.08206. T is for temperature and always has to be in the unit of Kelvin. From the ideal gas law, we can derive 3 smaller laws that isolate specific aspects. First is Charles' law, which deals with temperature, and it is volume equals a proportionality constant times temperature. Then there's Boyle's law, which is volume equals a constant for a given sample of air over pressure. And last is Avogadro's law, which is volume equals another proportionality constant times moles. Each of these laws can be used in cases where the other aspects are constants. A second major gas law is Dalton's law of partial pressures. This is for a mixture of gases in a container where the total pressure exerted is the sum of the pressures that each gas would exert if it was alone. So the P total equals the pressure of 1 plus the pressure of 2 plus the pressure of 3. Or if you write out the law for each one, it would be nRT over V for 1, 2, and 3 added to equal P total. When doing problems with the gas laws, it's important to remember a few things. Some problems will refer to a thing called STP. This stands for standard temperature and pressure, and it means that the conditions are of 1 atmosphere and 0 degrees Celsius. Sometimes problems will use other units than the normal ones for each variable. It is important to remember to convert from something like Celsius to Kelvin or milliliters to liters in order for the PV, nRT, or Dalton's gas law to work properly. Now we're going to do some AP practice problems using the gas laws. The figure above represents 3 sealed 1-liter vessels, each containing a different inert gas, 298 Kelvin. The pressure of argon in the first vessel is 2 atmospheres. The ratio of the numbers of argon, neon, and helium atoms in the vessels is 2 to 1 to 6 respectively. After all the gases are combined in a previously evacuated 2-liter vessel, what is the total pressure of the gases at 298 Kelvin? Take a moment, think about the answer. In this problem, you have to infer that the ratio they give you for the atoms is equal to the ratio of the pressures for each 1-liter container. But you also have to realize that in the final container, the volume has increased to 2 liters. So after adding up all the pressures, you have to divide by 2. 2 plus 1 plus 6 would be 9, divided by 2 is 4.5. Answer is B. Under which of the following conditions of temperature and pressure will H2 gas be expected to behave most like an ideal gas? Take a moment, think about the answer. As we discussed earlier, gases behave most ideally at high temperature and low pressure, and answer C has the highest temperature paired with the lowest pressure, so it is the correct answer. The average kinetic energy of the gas molecule is... Take a moment, think about the answer. As you should know, kinetic energy is related to temperature, and the 3 temperatures of A, B, and C are all the same, so the answer is D. The kinetic energy is also the same in the 3 containers. PCl5 gas decomposes into PCl3 gas and Cl2 gas, according to the equation above. A pure sample of PCl5 gas is placed in a rigid, evacuated 1-liter container. The initial pressure of the PCl5 gas is 1 atmosphere. The temperature is held constant until the PCl5 gas reaches equilibrium with its decomposition products. The figures below show the initial and equilibrium conditions of the system. Which of the following is the most likely cause for the increase in pressure observed in the container as the reaction reaches equilibrium? Take a moment and think about the answer. There's one thing to realize when looking at this problem. An increase of collisions is pressure. Because there are more moles in the second figure, the answer is C.